Okay, let's get started then. So I put together this little presentation about 15 minutes ago on malware. So one of my assignments for CS266 was to write a piece of malware. Bless you. And most people did this for Windows. I chose to do it for Mac OS. So I've got this little excerpt from a book right here. This book is called Computer Viruses and Malware, and one of the pages in it looks like this. So you've got an executable file. It looks like this. It's got a start location, and we can pretend this is executable code.
What is that? Is that address space?
Yeah, this is, for example, the text section.
Oh, the text section.
So one of the things you can do is append your code. If you're writing a virus, append some malicious code up here, and you would have to change the start location. So in every executable file that an operating system can run, there's header information. So for every Windows exe file, you've got a PE, that's portable executable, PE header, and that header contains all kinds of information laying out what's going to be executable code, what's going to be data, and when we load it up, where it's actually going to start executing. So if you do something like this, if you append your code to the top of the file, then you also need to change the header to say, okay, instead of going to the regular start location, which we can pretend is up here, so instead modify it so that it goes to some malicious code over here. Okay, so this is another example. So this would be the normal start location, and this here we have malicious code that we're appending to the bottom. We say, okay, change the address to the bottom over here, so it's going to execute my code, and after my code is executed, we're going to go back to the original start location, and it's going to look like nothing ever happened to the user. The program is going to continue executing like usual, but it's going to execute some malicious code when it starts up. Okay, I guess we can do a little background first. So I don't know if you guys can read this here. Okay, so this is for Mac OS, but there's analogous stuff for Windows as well. You would have to look at the PE header. So this is for the Mach-O, which is mock object. That's the file format that Mac OS uses. So the header looks something like this. You've got the header here, and you've got load commands, and those tell how we're going to load segments into memory. If you guys are familiar with Windows, there's usually a .text section, .data, you might have heard of that, and yeah, this is pretty much how Mac OS loads these sections into memory with load commands. Let's see, anything else over here? Well, why don't we go ahead and take a look at one. So here I have a whole bunch of target files. These are just basic utilities like cat, echo, move, hostname, remove, whatever. And I'm in this directory right now. So for example, if I do echo lol, or actually I should say /echo, so that we specified this one right here, echo lol. So you see it just prints whatever I'm typing, and there's nothing malicious about it. We could also do df to show I'm not sure what df stands for, but it basically gives you statistics about disk usage. So nothing suspect over here. These are just target files. And if we open one up, oops. So there's this program here called Mach-O view. And it actually parses everything for us. So just like I mentioned about the header, we've got the header over here. It's got some information saying, okay, this is for 64-bit. 64-bit x86. We've got all of our load commands here. So like I mentioned, this is how we're going to get the text segment into memory. And it tells us where it starts and everything. So text dash text, this is like your text section in Windows. And it even tells us the start address over here. So if we want to actually look at the text, meaning the executable code, that's right here. So anyway, the assignment was that we're supposed to make a dropper file. So the dropper is a program that's going to infect other files. It's going to actually drop that viral code into other executable files so that when those files are open, it'll execute the malicious code and then continue executing the regular files code. Alright, so basically the way that my dropper program works, we've got the text section up here. This is address, I don't know, I can't even read that, 1070. Yeah, so I prepended my viral code so that it's right on top. And then I changed the start address, which is in LC main. Entry offset. So this is going to be our entry address right here. And yeah, we can see it right there, 1070. So the dropper program, it writes malicious code right above the text section. It goes to LC main. It changes the entry address so that it points to that code right before the text section. And there's actually one more step that we have to do, and that's disable code signature. So in the load commands right here, there's a section, a load command for code signature, and that basically tells the operating system that before this program is run, we need to check that the signature is valid. So obviously it's not going to run if I inject my viral code because the code signature would be checked. So we have to disable that. Alright, so let's start with the viral code. Shellcode source. Okay, I think this is the one over here. So this is the viral code right here. We start off by pushing all of the registers onto the stack. I think this is push the floating point registers. Yeah, we basically want to save the state of all of the registers. Okay, and this is all done by system calls. So in order to open a file, what am I doing here? Okay, these are commented out. So I tried to obfuscate the code a little bit. So instead of writing out the text as a string, I did some stuff with moving binary bytes, moving ASCII bytes into memory, shifting them around, adding them, subtracting them a little bit. And so what we're doing here is opening up a file called infections.txt. I put a little bit of anti-debugging here with ptrace. What else? We open the file, we get a file descriptor. And again here, this is a little bit of obfuscation. So this is just building up the string "you're infected." And what this viral code is going to do is it's going to write the string "you're infected" to a file called infections.txt. So build the string, write it, close the file, and then after this we just pop, and then it's going to resume the normal code. Oh, the crew's here. Okay, what's next?
Sorry, guys.
Hello.
Our weekly ritual.
Hey, how'd you do at that tech thing? Yesterday.
It's open.
Sorry, guys. Thank you.
No problem. Okay, so the dropper program. The dropper program has several functions here. This program checks that the file has not previously been infected, and it's only going to cause the infection if it's not been infected before. And before it introduces the infection, it actually saves a copy to the user's home folder. So this is a nice virus. It's a benign malware. This is the code to introduce the infection. I don't know if we want to go through all of this. I wrote out an agenda, so we get the offset of the text section, get the offset for LC main, that's going to tell us our entry address. Make sure that they are the same. So I'm looking for an easy case over here, so that the entry address is actually the top of text. So we're going to make a backup of the file. We're going to skip code signing, calculate the new entry point based on the size of our shellcode, the malicious code. We're going to open up the file for write. We're going to write the modified header. Continue writing until we get to the point where we're supposed to enter. That's where we're going to write our malicious code. We copy the file up to the text section, minus shellcode. Yeah, so we write the shellcode and then write the rest of the file. So that's what the dropper does. Alright, and then why don't we go ahead and cause an infection. Okay, so hopefully this is still in a working state. So let's run the dropper. Usage is dropper, file to infect, and yeah, I think I didn't implement this, but anyway. So let's infect one of these. Well, before we infect the file, let's try one of them out. So hostname tells us the host name and no file, so no infection right now. Now what if we infect it? Nah, okay, let's try one. Read 8 bytes, found entry point, copy exists, I think I already have copies in my home folder. Yes, I do. Wow. So let me go ahead and delete all these first. All right, hopefully that's all of them. All right, where were we? So targets, these are all the target files. And we did /hostname. So no file over here. But if we infect it, did it work? Hostname, there you go. Now we can see the file. So you can see it works just like normal, but every time we run it, it's going to print a line over here. So if we infect another file, maybe df, now we run, so here's df, there's one line here. Now if we run df, now there's two lines. And what the heck, we can try one more. Let's infect Armen. So infections, two lines, let's rm. Oh. Oops. So rm just deleted itself, and if we, let's infect cat. Oh, well, before we infect cat, so let's cat infections. So there's 4 lines. Now let's infect cat. Now let's cat infections again. So now every time cat is opening, it's adding another line because it's infected. Yeah, so that's just a really basic virus. We appended it to the top of the text section, and we modified the file so that instead of pointing to the normal entry location, it points to our entry location. If you wanted to make this a little bit more difficult to detect, because this is pretty easy to remove the infection, you just change that entry point back to where it normally was. So if you wanted to make it a little bit more difficult, you could do stuff like shuffle code around so that you got some of the malicious code executing along with some of the normal code.
Where in the program do you print out the line?
Sorry?
Can you go back to your program, to the part where you print out, where you append something to the file every time?
In the assembly code?
Yeah.
Sure. Wait a minute. Yeah, this is the shellcode over here. This is what gets written to the top of the text section.
And this is being called by what?
This is being called by what?
Yeah, what is this part being called by?
This is being executed right on entry of the program. So this is not some external function.
Oh, okay.
When the operating system loads up the executable file,
yeah,
the executable file has been modified to point to right here, the top. So it executes from the top over here down to the bottom, and you see there's no return or anything. And the reason for that is because it just goes straight into the top of the text section.
There's a C program like this, right? Or is this it?
So the C program was the dropper.
Yeah.
The dropper is what writes this to the executable file.
Yeah. Can you go back to the C program?
Yeah.
Did you guys make Dropper, or was that just a tool that's available?
I wrote it.
Oh, the weekend.
Okay. Which file? There's a lot of different components here.
Infect.c.
Okay.
So what does this part do?
So this part is doing all this calculation up here.
Okay.
Calculate the address, calculate where the entry point is going to be, make sure that they're the same. It's making the backup copy and everything. And yeah, this basically opens up the executable and drops the assembly that you just saw into whatever you target.
Can I see the part where where it drops the assembly?
Where the code actually gets dropped.
Yeah.
Is that in here? Let's see. Write the modified header. Okay, so I modified the header, and this is where it's getting written to the file.
Okay.
And then we just copy the old file up to our new entry point. And then, so now we're at the point where we should be writing the shellcode, and that's what we do. We write the shellcode, which came from that assembly file.
Nice.
That was assembled using YASM. So I just took that code, wrote it to the top over here, and then we just write the rest of the file.
Have you tried using other shellcode? Like opening up the listener?
You could do that, sure. Yeah, you could open up a port, do basically whatever you want. And the thing that's kind of weird to me, I'm not sure why Mach-O files are like this, but if you open it up in a hex file, hex editor, a lot of times when you're looking to infect executables, you're looking for code capes. So those are sections of unused memory. A lot of times you'll see they're just a bunch of zeros.
Yeah, I see.
So where does it start? No, this is not the code over here. Okay, so this is where the executable code starts. This is the top of the text section. And you can see you have a whole bunch of space here to work with. I'm not sure why these files are like this, but that's something I noticed for Mach-O files. All of the header information is up here, and the code doesn't start until over here. So what I did was write all of my malicious code up here. It took maybe this much space. And instead of starting over here, it starts right here, executes, and when it's finished executing, it just goes straight into the normal flow.
Nice. How long did it take you to write this?
In terms of hours, not sure,
Or like,
but
how long was this project? How long did it last for?
Oh, they gave us a month to do it. I think I finished it in a couple weeks, maybe 3 weeks.
I'll see you too.
Yeah, pretty fun stuff.
I'll see you too at some point.
Any other questions?
What class is that called? It's 220 something.
This was 266. It's a special topics in security class, and this semester it happens to be malware. Next semester it's going to be reverse engineering, so the topic is constantly changing. Yeah. And yeah, like I said, a lot of this stuff applies to Windows as well. The format is just a little bit different. The way that the file is laid out, the start address and everything, it's a little bit different, but the concepts still apply.
Nice.
You have to be a grad student to take those classes? 266?
You can probably get instructor consent. Yeah,
From Snap?
whoever the instructor is. Yeah,
Who's it for screen?
Suppresso. Yeah.
Is that what you're taking right now? Or did you take this class with that professor?
No, it's STEM. All right then. Thanks for watching.
Suppresso's